Team 7 would like to introduce you to our Smart Fall protection harness system. For this, we're going to have Alan Thompson start off with a discussion around our fall hazard zone. Next up, James Ryan Kincaid will talk to you about the use of BLE technology in our tie-off notification system. Jerry Taylor will bring and talk to you about our fall incident notification system and what we're doing there. And then Floyd Sanders will bring it together and help you understand how we're using MATLAB to look at warnings, alarms, and escalation of events. Thank you.
Hello, my name is Alan Thompson, and the subsystem that I'm currently working on is the fall hazard zone. The fall hazard zone is basically the boundary areas that our system is going to operate in. We originally were going to use Wi-Fi triangulation and LiDAR mapping techniques to build the fall hazard zone. However, as we bought some of the equipment and started working with it, we realized that we weren't going to have enough time to be able to use these two techniques to map out the fall hazard zone. So instead, we have chose to use GPS to map the fall hazard zone, and we have purchased some small, inexpensive GPS units, and currently we're bringing in the data and analyzing it to see if we will be able to build a fall hazard zone accurately with it. Thank you.
Hello, my name is James Ryan Kincaid. For the Smart Fall Protection System, my primary task has been to develop and build a working prototype of the tie-off notification subsystem. The ESP32s and speakers have been acquired. The Bluetooth Low Energy puck has also been acquired. Additionally, the code required for the subsystem prototype has been written. As of now, the TNS subsystem has been built and there has been a successful operational check. My second phase of this project is to collaborate with my fellow teammates to collect the data from the fall indication notification subsystem and the fall hazard zone subsystem to produce a data stream to be sent through Wi-Fi via TCP/IP protocol to a central computer running MATLAB. Thank you.
Jerry Taylor here with a update on the fall incident notification system, the subsystem we call FINS. So far we have the circuit completed, tested, breadboarded, and the code has been written along with some testing on that. Here is the breadboarded circuit, simple voltage divider circuit with the conductive thread in the circuit. As you can see, the LED is out when the circuit is closed, and it lights when the circuit opens. On the software here, we can see that the circuit remains closed as a high number, and the alarm is low. And as the circuit is opened, the circuit number goes low and the alarm value goes high. Thank you.
So far, you've heard from Alan Thompson, James Ryan Kincaid, and Jerry Taylor, my teammates, who have been doing a great job pulling together all the good stuff in the ESP32s to get the data and understand, are we tied off? Are we in a fall hazard zone? And has the worker actually fallen? That leads via the ESP32 and the TCP/IP connection into MATLAB, which then processes all this data and tries to understand, well, where are we? What's the conditions? And how do we make that to where others can understand what's going on? Well, all of that is being done, like we said, in MATLAB. We have a data architecture established. We've actually tested the notification system. We have an alarm hierarchy established. And now we're going through and actually working the graphical user interface side of that. And it's really exciting because we're looking at how this project can actually help increase the safety of the workforce, the awareness of those who are looking out for them, and ultimately, hopefully, lead to saving some lives.